and you look into the block explorer and maybe look into secret or into a network, say we can even take someone else. Let's take neutron. So for example, you are on neutron. What are you going to do? First of all, you're going to check on your chain that's actually connected to secret network. So in that case, we can take a look at it, and we can verify, oh well, it's actually connected to secret network. So that means as long as secret and neutron are connected with a standard transfer channel that's just used for transferring assets, you're good to go. Now, what we can do is the second thing. So first of all, checking if you actually support your chain. In case you do not support that chain, always feel free to just contact us. We're happy to, maybe help out and create an IBC connection between your chain and secret network. So that's not going to be a problem. The next step is already just implementing the RNG contract. So what we have is we have a code example that Sean Red wrote, which is an amazing example, by the way. And that example is just, pretty easy to just copy paste into your code. It's meant to be not that be exhausting if you're just going to use it. So what we can do is, what you would usually do is you would just clone the repository and then just look at the example code and then just copy it into your contract. So this here is basically everything that you would just need to do to just compile your contract. In that case, we use Juno. But for example, this wouldn't be really much different if you would say use Neutron, use Arch, use whatever chain you know has Cosmos contracts supported. So in essence, there's actually not going to be a whole lot of things that you actually need to do in that regard. You would just implement it into your contract and it will work. So now we should actually go into just the example and then we can just take a look at it and I can show you the code, which is we can claim it's almost 10, 15 lines, not more. So in essence, what you need to do is the following. Key thing is here that you actually need to be able to verify signatures. So the kicker about the whole VRF thing in our case is that you are requesting or you are sending an IBC transfer message to secret network that contains an IBC hook. And that IBC hook basically says that we have a special contract with the secret network. It actually is able to receive these messages and actually is able to give you out a random number. As many as you like, actually. The important thing is that this is this contract here. So this is the contract we use on the secret network. This is already pre-deployed for you, so you don't need to do anything. What that contract essentially does is it just generates a bunch of random numbers here. It will encode them, and then it will actually assign these random numbers using its own private key. So that's the beauty of it. Since the execution state is encrypted, we can actually store a private key, assigning key inside of the contract that no one else is able to see except the trusted environment. In our case, it's using checks to do that. The important thing is that we are able to assign messages. That means we can take a bunch of random numbers, generate a lot of them, as many as you like. Then we can just sign this message using the contract. So the message actually signs this message and says, well, I've generated these random numbers, this is my signature. And then we're actually going to send these random numbers plus the signature and everything back to your source chain. You actually did that request. So that way, this is our contract on the secret network side. That's already been deployed, so you don't need to do anything. You're just going to call our contract. And then on your source side, actually, what you can do is the following. Just get into this. Okay, so what you can do now, this is basically everything on the secret network side. This is nothing you need to worry about. If you like, of course, you can check the code and maybe actually use it in your contract as well. The idea is pretty simple. You can actually sign messages using SecP256K1 and use SecP256K1 if you like your contract. So maybe you want to do some other things, some cross-chain stuff or some interesting stuff that you want to do. They actually need to send messages. You can actually use the code in your example. That would be pretty easy, actually. So say you're going to use this contract. Again, this has already been pre-deployed on the secret network. We have it all in our examples here. So it's all in the example that we have. And basically Sean made sure that everything is correct in that code example. So you don't need to do anything. As you can see, we hard coded these country addresses, and we also included a verification key. So this verification key is actually the public key of the uh, of an RNG contract that I just showed you. That's been deployed on Secret Network. And if you are getting an incoming message, you're actually verifying that this message is actually signed by this corresponding public key. So that way you can always verify that it actually came from the contract in Secret Network. And in our case, for example, we had Juno, we had Akash, and Archway as well. So these are all already let's say pre-deployed channels that you already can use. So these channels are also used not normally for just IBC transfer messages, to transfer assets around from Secret and to these chains. So there's no, how to say, specific problem for you. So you would just include your chain, or if it's already on there, then you're already fine. Important is you need to keep these constants there, because these are actually this is the RNG contract on Secret Network, and this is the verification key. So you need to keep these. In your function executions, it's not going to be pretty hard. What we did, for example, is we did just two functions, which one of them obviously is just a function that just requests a random number. You can always attach a random job ID to it. The job ID is just meant for you to be able to track actually what request are you going to do, because what we can found as well, you can obviously request random numbers, but I think you need to actually assign them to a certain, let's say, play or certain game, and that way you can actually use the job ID to implement it. It's actually been pretty close to how Noise is implementing their stuff. So we made sure that maybe if you can't go from Noise and using Noise randomness, you might also want to take a look at this, as it almost has the same structure, and it's also way easy to use. So now to get in, we're gonna request the randomness. We're gonna do that. This function is the code part that you're gonna use here is this one. So you're gonna actually create an IBC hook memo, which here just calls WASM contract. That WASM contract is actually just our CP contract address. You will also include we're actually gonna call a request random function on that our CPVF contract, and you're gonna provide a job ID. That job ID is just something that you pick. Again, the idea behind it is that you can use this to assign a certain VRF outputs, or requests, to whatever you like. Then we're gonna have a secret transfer channel ID. So this is the channel ID that we defined above. That means we're gonna send an IBC message into specifically. This is basically the channel that you're gonna give over Secret Network, and Secret Network that way knows basically where to send actually that message back. Because how should the contract actually know where to go afterwards? Basically, after it gets the numbers, it actually has to know where's this message gonna go afterwards. This is the channel that you want to use. So this is the channel that's going in. So you're sending in a message in channel 40. And for Secret Network, if you're going back, you're actually going to send a message to this channel, which actually brings it into. So that way, you're going to define your transfer channel ID, and you are going to define your contract address. In that case, that's going to be the address basically that you're going to call afterwards for the callback. So we're going to have a callback address, and we're going to have an IBC timeout in that case. Callback timeout in that case, we're going to do 15 minutes, but you can just pick whatever you like. In that case, it would be 900 seconds, but you can pick more. This is also something that you can mainly just copy over. So here you can customize some smaller stuff, but here, for example, you can actually just copy over that stuff, this is just used to actually create a target message that just does the IBC transfer. It's been actually on purpose to use any buff, because what you can also use we thought we wanted to have a chain agnostic, so we're not gonna have like specific types, any problems. If you use any buff, you can easily just copy in and stuff, and it will work for you. Idea behind it was that you just simply have something that is straight, easy to copy over and use. So, for example, if you want to do that IBC call callback hook, you're actually able to request more than just one random word. For example, in our case, we just hard-coded to one random word. If you like to do more, obviously, you can also always add this in this example here, by modifying this JSON file here. So yeah, that's basically what you only need to do to request actually a random number. As you can see, it's not really that hard. In case you have problems in using this code, please do not hesitate to contact us. We're really happy to help you out with this, and we try to make it as simple as possible, but can always be something that just goes wrong. Especially if you want to maybe do like more than one random word, we're happy to help you out and how to improve it. So after you send IBC message, actually you're gonna construct an IBC message and you're gonna send it out. What's gonna happen is the chain is it's what's gonna be S in that example is maybe 0. It's an IBC message to secret network, and then it's actually going to call that randomness contract we deployed for you. Already pre-deployed, nothing that you need to do. There's no hassle to actually work on secret. You're not actually not gonna touch secret in any way. So you can send in some of your tokens that you have. For example, this has to be like a pretty small amount. Important thing is it's just going to be like a super small amount here. In that case, it should be just you're just gonna send in one microjuno, one microneutron, whatever is fine for you. Important is it just has to attach some small values to it. Aside from this, IBC is going to take care of everything else. Relays are going to take care of everything else. So you don't need to actually worry about anything of this. At that point, your work is done, and you can just sit back and wait until you receive a random number again. So what's going to happen is we generate the randomness, and then what we're going to do is we're actually getting a callback. So what it means is that we're actually going to send back another message over IBC into secret network, and from secret network into your chain. So for example, Archway, Arcash, Neutron, whatever you like. And it's actually going to use an IBC hook to actually call that receive function. So what you're going to do is, at that point, the IBC stuff, transfers over the randomness into your chain, and then it's actually going to use an IBC hook. So again, a message inside an IBC memo to receive that random number. So it's actually going to call this contract again that you originally had. And it's actually going to call the function receive random, and it's going to give over the job ID that you defined before, so that way you can track a random number, and it's going to randomness, and it's going to give over the signature. And the idea behind it is basically that the contract, as I've said, created the randomness, and then it signed the randomness using its own private key that's only available on secret. So only secret contract can actually sign a message that way with a private key is actually, not openly visible to the chain. So what the idea behind it is, I'm gonna get it now. So the thing is, since the random number was actually transported across the chain, there actually might be, maybe some way to actually, inject wrong randomness. So using IBC hooks, it has like a very flexible, it's a pretty flexible way of actually, sending stuff around. It's actually possible that someone else could randomly, or just maliciously call this function receive random, because it's actually IBC hooks are just not, you don't need to specifically use an IBC hook for this regard. Maybe sending some other message, or you could potentially inject wrong randomness, false randomness into it. So that's why actually a signature that we actually to verify that this message and this randomness actually came from our contract in the secret network. Otherwise, it's not going to work, because again, you said otherwise anyone else could actually inject false randomness into your contract, and that way, could manipulate games, which is not something you want. So the main part of this is actually not really that extremely fancy. It's mainly just taking the randomness, and it's just verifying that the stop ID and randomness actually is coming, was signed by our verification key. So this is the verification key that's here that you basically trust on that side. And this is only what you're going to do. So what you're going to do is you take the job ID, you take the randomness, and you will just check if this job ID and randomness actually fits its signature. And this is everything we're gonna do in this contract. There's nothing more special stuff that we're gonna do. So what we're gonna do is we're just gonna, first hash this value. So what we're gonna do is on the secret network side, what we did is we took the job ID, we took the randomness, and we just concatenated. And what we did is we hashed these together using SHA-256. So that's what the secret network side always does if it actually gets a signature. So we're actually taking a SHA-256 hash of this concatenated values here, so job ID and randomness that we have. We're gonna concatenate them, and then what we're gonna do is we're actually gonna hash this and create a SHA-256 hash out of it. After this, it's actually fairly easy. What we're gonna do, we are going to do a signature verification, sec p61 signature verification of that hash, and that hash and this signature. And of course, we're gonna check if that obviously corresponds to that your FP. So what we're gonna do is actually fairly simple. We have obviously our hash results, so our hash, 32 bytes. We have our signature that we got from the from the contract, from IBC from a signature expert as well. And then what we also have is we have this verification key. In that case, what we wanted to do is we wanted to keep it super simple. So what we did is we just hard coded it as a base 64 string. That base 64 string always needs to be converted into just a byte sequence. So we're going to actually code this as well. And the signature is also encoded as a base 64, so that way we can just use it as we like. So yeah, that's exactly it. So the randomness string is also just a base 64 encoded string, so that way you can just easily verify it. We just want to keep it simple, not make it too hard, and it doesn't really make a difference for us if you would have a base 64 string as randomness, or if you just decode it into a byte sequence. So what we're gonna do is we're just gonna verify using sec61, which is pretty much standard in all Cosmos libraries. So if you chain support, if you have Cosmos in the chain, you should have this. And this will verify that this signature actually belongs to that hashed result, and in turn actually corresponds to the correct job ID and correct randomness that we provided. Exactly. And what we're gonna take if the signature is correct, and if the signature is not correct, obviously it's gonna throw an error. And if the signature is correct, then you can be sure that this has actually been signed by the contract, and not only that it has been signed, but also, of course, that it was obviously transmitted successfully between your chain and the between your source chain and the network. Yeah. And after this, you can do whatever you need to do. You can obviously just use the randomness, to use it in your games. You can use it for raffles. You can use it for DAO tooling, maybe to create some randomness aspects. You can use it in a bunch of stuff. Really excited to see what you're doing specifically. And obviously, it's a pretty flexible tool that we have here. So obviously, not going to have any it doesn't need any fancy IBC channels. It can just be classical IBC transfer channel on each chain. The contract doesn't need to do anything else. It just needs to basically take secure into your contract, and it will work almost out of the box. In case it doesn't work out of the box, we always have to have it's really a long part of code. Sometimes just stuff goes wrong. Really, we have to have out if there's some weird problems with it. But in essence, we want to make this like a code that's pretty easy to drop in between contract, almost any IBC chain, drop it in and make it work. Exactly. And in our case, we just added some attribute that says, well, the someone was just successful. This is a check message, but that's not, doesn't need to be done. Exactly. So that example is actually pretty small. In that case, it's not 10 lines. We have it in EVM pretty much, except if you were to take this as one line. I wouldn't do that trick though, but it's a really fast and efficient way to actually get IBC and verify randomness on your chain. There's no special contracts needed. There's no special, fees needed. Nothing. Everything is paid for you. Contract doesn't need anything specific in token, so you just send a request and I will get it back. That's it. The relayers are going to pay a fees and just pay whatever you see. So that's the whole rundown of it. That's already enough to do for you. So you don't need actually to do anything else to do this. You basically need to copy in that code, copy your address, look up what your transfer channels are for your chain, and then you just need to drop in the code to receive random numbers and this code to generate random numbers. That's it. Simple, fast to do. And yeah, that's all I have for you today. That's already a pretty fast tutorial, I'd say. It's actually meant to be this way because that way, it should be if it's so easy to explain, obviously imagine how easy it is to actually implement it in your contract. It's it's one of the easiest and most elegant ways that we found is you know feasible and also while being secure as well. So of course, you want to make sure that obviously you are not getting manipulated random numbers. That's really most important for us. Okay, so that's already a workshop. Um, so the contract side is obviously easy to pull off. We would be really happy, if you have questions for it, when you use it, just drop us a link, drop us, a message on Telegram, drop us message on Discord. Maybe the next, you know, dev call next week. So we're gonna have obviously we have a weekly dev call on Monday. So in case you got questions for this for HackSecret, please stop by. Questions would be helpful. And to help you out. Yep. So without that, with that out of the way, we are actually done with that workshop. So we have any questions from the audience? So for example, we also have the randomness here provided, so that's by 64 string, 32 bytes, and a signature attached to it and a receiver. And this is a pretty good example. So in that case, and stuff works, we're gonna have like one IBC transfer in, one IBC transfer out, obviously. So that was the IBC transfer out, and that contains this random number and the signature verification. So the random is actually what you're gonna use. And again, any questions on Discord or where's Telegram, whatever is nice. Exactly. I'm gonna stay here for another 5 minutes, and we're gonna close up that call. In case you have questions in the meantime. Thanks a lot for joining, everyone. And I hope to see you for the next workshop as well, which is going to be on Tuesday. Let me see when we can later. Set dates for you. So you can always, of course, look at the HackSecret Free Hackathon. Always look at the schedules. And as you can see, the next workshop is going to be next week on June 4th, launch on mainnet. And of course, you're gonna and join. And then I'm also gonna have another workshop on June 6th, which is the EVM tutorial. So in case you're going to do stuff with EVM and not with IBC, you can easily, use it for EVMs. We have another very nice implementation for EVM that actually makes CRF pretty easy to use. It's even easier to implement than the IBC. Exactly. So let's just wait another 5 minutes, and then we're gonna put it back on. Thanks everyone for listening today. We hope to see you next week. So I think there are no further questions or anything. So let's just end up the call. Thanks everyone for joining today, and we'll see you on June 4th. Bye.